When we talk about artificial intelligence in aviation, many people imagine autonomous cockpits or pilots being replaced. But the reality is different. AI in the cockpit is not here to replace pilots, it's here to empower them. Today, I'm going to explain, step by step and in detail, what AI actually does in the cockpit and how it does it. From the simplest tasks to the most complex ones, we'll explore how information flows, how AI processes data, and why its responses are fast, accurate, and reliable. The integration of AI in the cockpit starts with basic but essential tasks. AI can handle routine communications via CPDLC and ACARS. This relieves the pilot from manually coordinating messages and reduces the risk of communication errors. As we move forward, AI evolves into a digital co-pilot that assists with navigation, manages communications, verifies procedures, and keeps track of pending tasks. But it doesn't stop there. AI begins to deliver real value when it processes real-time information and directly assists with tactical decision-making during the flight. AI analyzes massive amounts of data in seconds to optimize flight routes. These data come from weather systems, air traffic information, fuel efficiency metrics, and airport conditions. This allows AI to suggest safer and more efficient routes, not only during pre-flight planning but also while the flight is underway. AI also supports air traffic management by monitoring aircraft positions, anticipating possible delays, and proposing deviations to avoid congestion and minimize risks. Most importantly, this support is not reactive, it's predictive. Why is AI in the cockpit so effective? 3 reasons: precision, speed, and reliability. First, precision. AI doesn't work with limited data or rough estimates. It processes information from radars, sensors, real-time weather conditions, flight parameters, air traffic, and maintenance records, all at the same time. This massive analysis enables AI to detect subtle patterns, such as unusual speed changes or trajectory deviations that the pilot may not have noticed yet. Second, speed. AI processes and correlates huge amounts of data instantly, thanks to specialized architectures like ARINC 429 and AFDX, ARINC 664, that enable the efficient flow of data between sensors, navigation systems, and communication devices. Data travels through dedicated networks within the aircraft, with additional support from SATCOM and 4G connectivity when the aircraft is on the ground, ensuring uninterrupted information flow. Third, reliability. AI is not only fast and precise, it operates under strict certification standards like DO 178C, which guarantees software safety in aviation systems. Its infrastructure is also protected under protocols like DO 326A, which ensure resilience against cybersecurity threats. This regulatory framework ensures that every suggestion or calculation AI makes is consistent and safe. But in order for AI to deliver this real-time precision, speed, and reliability, it needs something fundamental: a constant, organized, and secure flow of critical data feeding its every decision. AI depends on a constant flow of data to make accurate decisions. Aircraft sensors, monitoring engine performance, structural integrity, fuel levels, temperature, speed, and other critical parameters in real time. Weather systems, collecting data from satellites, radars, and external sources like aviationweather.gov, allowing AI to anticipate turbulence, fog, or storms. Radars and ADS-B, providing real-time information about the position, speed, and trajectories of other aircraft. Operational databases, containing flight plans, navigation charts, and historical data. All this information is transmitted via ARINC 429 and AFDX data buses, and also through SATCOM for global and ground-based connections. AI fuses these data streams, compares them with historical patterns and real-time conditions, and delivers pilots clear, prioritized alerts, suggestions, and recommendations. This process includes multi-sensor fusion, where data from GPS, radars, cockpit sensors, and communications are cross-referenced to create an integrated view of the flight, something no human could process alone. Once AI has processed the data, the next step is how it presents the information to the pilot. This is where the human-machine interface, HMI, comes into play. New generation cockpits use predictive voice assistants, adaptive screens that prioritize relevant alerts, systems that adjust displayed information based on the flight phase and pilot workload. AI helps pilots to filter out irrelevant information, prioritize urgent decisions, receive real-time actionable suggestions. The most important thing is that AI does not take full control. The pilot always has the final say. AI is a co-pilot that observes, analyzes, and suggests, but it is always subordinate to human authority. Artificial intelligence in the cockpit is much more than just a trendy technology. It's a tool that processes data at a speed humans can't match, with surgical precision and reliability backed by rigorous certifications. From managing flight routes and communications to anticipating hazardous conditions and supporting continuous training, AI is redefining how we fly. The key is understanding that AI does not replace the pilot. AI empowers the pilot. Control, responsibility, and final decisions will always remain in our hands. But now, we fly with a co-pilot who never blinks, never gets tired, and is always alert. Fly safe, my friends.